Tukienda kwenye mifano, we have a body in a weight at 27 Newton in a hang on a long spring such that that an extra force of 9 Newton stretches the spring at 0.05 meters. If the body is pulled downward and released, what is its period? So we know ukipewa force na ukipewa extension una spring constant. So we know the time period is given 2 pi m over k. So m over k, we have the mass ambayo tumepewa weight kwa tukidivide by the acceleration due to gravity ambayo 27 divided by 9.8 tunapata mass, divide by the spring constant ambayo tunaweza tukaipata because we have the force, we have the extension. Tumeshaambiwa spring constant sasa na force over extension is according to its law. So tungeweza kutumia formula 2 pi E over g, but be very very careful. Okay, I told you mwanzo kwamba always make sure the extension you are using is corresponding to the restoring force you are using. Okay, usije ukatumia extension ya kitu kingine na force ya kitu tofauti. Kama extension imesababishwa na weight, then you are safe to use this formula. Lakini kama extension haijasababishwa na weight, usitumie hiyo formula. So better find a way kutumia m over k. Why? Because ukisema utumie hii extension 0.05 utumie na hii acceleration due to gravity, utakosa. Fanya utaona it doesn't give you the answers. Why? Because this is only true when the extension was caused by the weight. Okay, if you can remember, if the extension was caused by the weight, that's when the formula will give you the correct answer. Otherwise, that here the extension is caused by extra force ya 9 Newton. So do not confuse yourself ukajichanganya ukataka utumie hiyo extension. Okay, utumie hiyo extension ya 0.05 uje kutumia na gravity, you'll miss the question. So don't do that. Okay, yes. So we have another question here, that a 50-gram mass hangs at the end of hook and spring. When 20 grams more are added to the end of spring, it stretches 7 centimeter more. So this 7 centimeter is due to the 20 grams and not due to this weight. Okay, ndio maana amesema 7 centimeter more and 20 grams more. More na more wanaenda pamoja. 20 grams na 7 centimeter. Find the spring constant. Well, since the spring is linear, force, restoring force divided by the extension tunapata spring constant. So we are having the force, which is the extra mass 20 grams changing to kilograms, multiply na g, the acceleration due to gravity, ili upate weight, divide by the extension ambayo ni 7 cm converted into meters, unapata spring constant. If 20 grams are now removed, what will be the period? It means if 20 grams are removed, the oscillating mass is only 50 grams. Okay, hii imekusaidia kupata spring constant. So you know time period is the mass of k. The mass is 50 grams, the spring constant is 2.8. So simple like that. Okay, again we have here an example, a 1.55 gram block sliding, kilogram block is sliding in a frictionless horizontal plane. So this is the diagram here. Okay, this is the horizontal plane. We have the spring, the body is attached. Okay. So it is sliding to and fro kwenye horizontal plane ambayo ni frictionless. Otherwise kungekuwa na friction, it means if this body could be coming this way, kuna friction na opposite ambayo ingeleta kitu tofauti kabisa. Okay, let's connect force hapa, ingekuwa ni hiyo force restoring, the force now pull the body huku minus the friction. but now it is frictionless, so we don't need to worry about that. So spring constant tumepewa na block is pulled to the right. It is pulled to the right. Distance here, distance here, yeah, 0.0575 meters. Okay, released from rest. What is the block's velocity? 1.5 seconds after it is released. Okay, so we remember tulisema kwamba, I'm bringing you here down, tulisema kwamba displacement ni sawa sana A sin WT. Okay, lakini tulisema this is only true when the body imeanza kuoscillate on its mean position. Nakumbuka tunaongelea mambo ya phase angle, please go back and review. Na tukasema tena tulikuwa tunaongelea mfano wa a cycle. Okay, kwamba if the body starts from here, tunatumia hapa. If the body starts from here ikaenda to another point there, it means formula yetu inakuwa modified, inakuwa ni A sin WT plus phase angle. Okay, tulisema hiki hapa kitu. Na tukaenda mbali tukasema principles za mathematics zinatuambia kwenye identities sin ya WT plus phase angle ni sawa sawa. Hii ni sawa sawa na cosine ya the first angle upon WT. Hizo ni hesabu tu. Kwa hiyo A cos ni sawa sana tukiandika A cos ya WT. So velocity tulisema tuna differentiate displacement with respect to time. So we have dx dt ambayo ni velocity. Ni sawa sana A, tukisema W inatoka nje, the sign ina change, inakuwa kutoka cos inaenda kwenye sin WT. But it is this simple. So A times 2 pi over T sin 2 pi over T times time. Remember to put your calculator in radians. Narudia tena, otherwise you get wrong answers. The amplitude is a technique ya maswali ya spring. Amplitude is always the distance you pull the object. Yani principle ndo wako iko hivyo. Ukitaka kuanza oscillate spring, ile distance utakao pull, the spring will be moving with that amplitude. Kwa kama hapa ameipull distance ya 5.75 cm au 0.0575 meters, hiyo ndio inakuwa amplitude yake. So you have the amplitude, you have the time, the 2, the pi are constants, 2, the pi are constant, you have the time ambayo ni 1.5, but you don't have the time period. But you know time period is sawa sana 2 pi divided by mass over spring constant. Spring constant tulishapewa, the mass tulishapewa. So you put in the numbers, you get something like this. Plus you get your answer. Simple like that. It's a little bit complicated here. I've tried to simplify for you here. So we have another example here. A spiral spring gives a displacement of 5 for a load of 500 grams. Find maximum displacement produced when a mass of 80 grams is dropped from a height of 10 centimeter onto a light pan attached to the spring. Okay, so this has something to do with energy change. Okay, so I would rather reserve this question kule kwenye maswali ya energy changes, because they involve changes they are dropping from height, it means 10 centimeter kuja chini, converting that potential energy to kinetic energy, inaenda pale kwenye spring ina transmit that kinetic energy and all that. So you can come back to this kama assignment yako. I will be glad if you share the answers with me, kuona kama umepata umekosea. So tukisoma energy change, you can come back to this as it will be easy. So we have another example. A body of mass 12 kilograms suspended by a coil spring of natural length 50 centimeter na force constant hiyo hapo. what is the stretched length of the spring. So we know kwamba stretched length of the spring is just given by ukishaweka weight to pap, ukiweka ile mass pap, si spring inaongezeka. So we know force mg tulisema ni sawa na kx. So utafute hii stretched length. For x ni sawa na mg over spring constant. You have g, you have spring constant, umepewa the stretched length in 5.88 centimeters. Yeah, so that is the extra extension. So the stretched length will be a summation of the natural length plus the extension. For total, the 50 plus 5.88 meters, you get total stretched length there, 55.88 centimeters. So you are supposed to find the frequency of oscillations umeambiwa neglect the mass of the spring. Otherwise, ukiwa na mass of the spring, it means total mass inakuwa ni oscillate ni mass ya body plus mass of spring. All those cases tumekuwa tukiassume these are massless springs. So it's just simple. Frequency period ni kunakuwa 2 pi m of k. Frequency kwa the vice versa. Kule tulishaweka, you just put in the numbers, get the answer. For the motion of mass suspended by a coil, okay, we don't have the example here. What is the next force suspended in the lowermost position? Okay, we don't have the diagram, so we might not be able to get the answer. But hili swali lipo kwenye chand, please go and check it out and see what we can do about it. So we have another example here. Consider two discs with a massless spring of force constant. Here, calculate the frequency of oscillation of the spring when the system is resting on a table. Kwa system ikiwa ina rest on table, kinacho oscillate ni mass ya juu tu. So we have frequency 1 over 2 pi k over m, the spring constant tumepewa. Mass ina oscillate ni ya juu tu peke yake. So we have 5 per second. So when the table is removed, now the system is falling freely. Okay, kwa hii table imemove, this system iko kwenye air ina fall chini. Okay, so we have this mass pulling and this mass pushing. So as we said earlier, kwamba ikiwa a system, unakumbuka previously kunyuma kabisa, yeah, I told you kwamba it's either you have a single mass, 2 springs, total spring constant itakuwa hivi, or a single spring, 2 masses, total masses itakuwa hivi. So it's just what we are applying here in this question. So we have a system falling freely, and if it is freely, the new mass that is falling freely is given by that. So now calculate that, unapata the resultant mass, you put in the formula, you have the spring constant with you. So everything is just Gandarandis. Yeah, so we have last example. The final question of a time period of a mass suspended from a spring, spring constant of k. It's if the spring is cut into 3 equal parts, same mass is suspended from one piece, what will be the time period? So you have a spring, initially you had a mass here, you had one spring, ambayo it means time period at that point ilikuwa ni t is equal to pi mass over k ambayo ni the whole spring constant k. So now you have cut this into 3 parts, and umechukua kapati kamoja, kakipande kamoja, equal parts, kakipande kamoja umekachukua sasa kakipande, umening'iniza ya mass. What will be the time period? So first formula yetu ni ile kwamba time period ni sawa sana 2 pi m over k for this k dash to it of the new spring k dash. So we know kwamba k 1 over k, springs zikiwa in series kama hivi, 1 over k ni sawa sana 1 over k1 plus 1 over k2 plus 1 over k3. But hizi ni 3 equal parts, so k1, k2, k3 the same. So 1 over k ni sawasawa na 3k1 labda tuseme, because k1 is equal to k2 is equal to k3, so zote ni k1 tuseme. Yes, so k, total k inakuwa ni k over 3 of one of the cut springs. Sawa, kwenye zile cut springs ukizichukua, cut springs k1 ukizichukua ukazikata unapata springs 3. So ukichukua ya moja hapo ukadivide by 3 ndio ile k kubwa ambayo ingekuwepo. Sawa, na ndio maana kuziarrange springs in series tunafanya kwa this formula. So kupata k1, it means k1 hapo ni 3 times k. Simple as that. So 3k ndio alichokifanya hapo, 3k kwamba ni sawa na 3 times kama spring ingekuwa peke yake. Umeona, ni sawa na 3 times kama spring ingekuwa peke yake. Kwa kumbe kuikata ni kuongeza spring constant. Yeah. Kwa hiyo time period, new time period ni sawa na 2 pi times mass times the new spring constant k dash ambayo ni 3k ile mwanzo. Yes, simple like that. So if you find the ratio between this and this, utapata t dash divided by t ni sawa na 1 over 3 kwa sawa na this one. Simple like that. So we have practice questions here. You can practice on your own and you have answers there, so please try that and see how far umenielewa.